Welcome back to Sefton Motors. We've got a Volo 1 engine update for you. We've got some exciting things that have been going on. I know it's been a long time. We've had a lot of changes at Sefton Motors. Now we're in a new facility, 1,400 square feet. We're building engines there. We're changing the systems in the engines to make them more robust, and things are really starting to move. We've got updates on the castings for the engine. We've got updates on the kinematics. We've got updates on the pressurization system for the engine. And I'm excited to tell you about them. I'm going to take you through each one right now.
All right, let's start with the facility. 1,400 square feet in Pontiac, Michigan. Not exactly the most charming city in the world, but rent's cheap. You can see inside we're getting good light. We've got some of our mottos up on the wall. We're starting to build inventory in there, and that's the key thing. We'd like to get to a point where we're working off an inventory base instead of making to order. Here you can see we've got 3 engines in production and making more. It does get awful cold in there, though, I will give you that. Wintertime can be a little rough. What we're doing now is we're using a 3D printer to establish some of the molds needed to make castings. One of our slowest pieces for production is the castings, and so we're outsourcing that to a local place in town here. We're starting with making the patterns with the 3D printer, as you see here. And then what we do is we take that 3D printed mold or pattern and modify it so that they can then make their core boxes from that. And it looks something like this. We smooth it out so they can work with it, and then we send it on over to Warner Brothers Casting over on Groesbeck. They make some boxes like this, and then once it's poured, it goes in the shaker, what you're seeing here, which looks like absolute heaven, hell on earth, but it seems to clear the sand off the mold. Once that shaker is completed, then we get the start to see the final form of the product, and as you can see, castings really do come out wonderfully. We do that for the piston, for the coal cylinder, and lastly for the head. And that's what you're looking at right here. With the displacer. Now, in addition to the regen section, which is in the center of the displacer here, we've replaced the aluminum with the copper. And we do seem to be getting a better performance, but this remains a component that still needs attention in the engine. You know, we show you a lot of things here, a lot of things that are working. You know, there are a lot of things, a lot of times where things just don't work. So I'm going to digress here a minute, and a lot of times, you know, what we're feeling here is something like in this short clip here. See if you can relate.
Let's try this out. Holy smokes. A little too much magnesium, I guess. I won't do that again. Sorry about that.
I love that guy. All right, now back to the engine. Now let's look at some of the overall engine changes that have happened in this version. The overall length of the engine is shorter by 6 inches. The poundage is reduced by 50 pounds, probably 20 of that out of the flywheels. The warm-up time has been reduced to about 12 minutes now. And the kinematics have all been reworked. We've got spherical rod end bearings back there that are really working well. And it overall is a much tighter package. What I want to talk now is about the pressurization system. As you know, our pressurization system in the past was basically a chamber built around the engine that was externally pressurized, and really the seals leaked, and it just was not a very efficient or elegant design. We've changed it now. We've looked at a self-pressurizing system for the engine, one that has a mini piston inside the displacer tube that actually injects small quantities of air into the chamber as the engine runs and gets up to speed. If you're looking at the kinematics right now, you'll see that the displacer tube has another rod in the center of it. At the end of that rod is an actual piston. And the relative motion of that piston with the rod coming back actually injects air into this system, into the main chamber of the engine. What I'd like to do now is to take you through a cycle of that, just hand turning the engine so you can see how that action works. It holds some good opportunities for us in this configuration. Displacer tube, and since it's attached to the swing arm in the back, it actually creates a pumping action that forces air into the main chamber of the engine through a series of check valves that are within that displacer tube and then within the displacer collar itself. So as the engine cycles, the piston stays relatively stationary with respect to the displacer, but that tube is coming back, forcing air into the main chamber. All right, guys, that's going to about wrap it up for our update tonight. We're working hard. We're making progress. Next up is power output and remote start and monitoring. We'll see you soon. Thanks again for all the support, and enjoy. Watch out for that magnesium level. So long.